Hi, welcome to my channel. In this video, we want to solve the following problem. Given a circle, let ABC be an inscribed equilateral triangle with a side length of square root 3 units. Construct a square PQRS with P and S lying on BC and Q and R lying on the circle. The goal is to find the area of the square PQRS. And now for the solution. First, let's calculate the area of triangle ABC. To do that, recall that given a triangle with sides A and B and included angle alpha, then the area equals half AB sine alpha. Since the interior angle of an equilateral triangle is 60 degrees, the area of triangle ABC equals half times square root 3 times square root 3 sine 60 degrees. Since sine of 60 degrees equals square root 3 over 2, the area equals 3 square root 3 over 4 square units. Next, let us calculate the circumradius of triangle ABC. To do that, recall that given an inscribed triangle XYZ with sides A, B, and C, the circumradius equals ABC over 4 times area of triangle XYZ. If we let the radius of the circumcircle be r, then we have r equals square root 3 cubed over 4 times 3 square root 3 over 4. Therefore, r equals 1 unit. Next, let us denote the side length of the square as A and the length of BP as B. Then by symmetry, the length of SC also equals B. Thus we have B plus A plus B equals square root 3, or 2B equals square root 3 minus A, giving us B equals square root 3 over 2 minus A over 2. Next, let us calculate PC, which equals A plus B, and thus equals A plus square root 3 over 2 minus A over 2, or square root 3 over 2 plus A over 2. Following this, extend QP to meet the circle at M. Denote the length of MP as H and then consider the lines MQ and BC and the circle. Let us apply the intersecting chords theorem. Given a circle with two intersecting chords, the theorem tells us that A times B equals C times D. By the intersecting chords theorem, we have AH equals square root 3 over 2 minus A over 2 times square root 3 over 2 plus A over 2, which simplifies to AH equals 3 over 4 minus A squared over 4. After dividing both sides by A, we square both sides to obtain H squared equals 9 over 16 A squared minus 3 over 8 plus A squared over 16. Next, connect R to M and then consider triangle MQR and the circle. Since angle MQR is an interior angle of a square, it is a right angle. Recall that a right angle is subtended by a diameter. Therefore, MR is the diameter of the circle. Since the radius equals 1 unit, the length of MR equals 2 units, while the length of MQ equals H plus A units, and the length of QR equals A units. Then by Pythagoras theorem, we have H plus A whole square plus A square equals 2 square. Expanding the brackets gives us H square plus 2AH plus A square equals 4. Substituting for AH and H square, we obtain 9 over 16 A square minus 3 over 8 plus A square over 16 plus 3 over 2 minus A square over 2 plus 2A square equals 4, which simplifies to 25A square over 16 minus 23 over 8 plus 9 over 16A square equals 0. Multiplying both sides by 16A square gives us 25A power of 4 minus 46A square plus 9 equals 0. An application of the quadratic formula with alpha equals 25, beta equals minus 46, and gamma equals 9 gives us two possible areas of the square, 23 plus 4 square root 19 over 25 and 23 minus 4 square root 19 over 25. To determine the area, let us return to the diagram. Construct diameter AD and label the intersection of AD and BC as N. Since angle ANC equals 90 degrees, angle NCA equals 60 degrees, and the length of AC equals square root 3 units, then AN equals square root 3 sine 60 degrees, which equals 3 over 2 units. ND, which is given by AD minus AN, thus equals 2 minus 3 over 2, or 1 over 2 units. Since PQ is less than ND, we have A less than half, and so A squared less than 1 over 4. Since 23 plus 4 square root 19 over 25 is approximately 1.62, and 23 minus 4 square root 19 over 25 is approximately 0.22, the area of the square is 23 minus 4 square root 19 over 25 square units. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.